Hi, Vijay. Thanks for joining us to this session. And my name is Ankur Bhattacharya. I do have around 9 years of experience in IT, and for the last 7 years I worked as a data engineer. Current organization as an assistant manager, mostly in AWS cloud, but I have also expertise in Azure. Why don't you start with your intro and what kind of project you are working on, what kind of tools you have used, etc.
Okay. Hi, Ankur. I have around 4.5 years of experience in IT, out of which 2+ would be into data engineering. And if you come to the tech stack, basically for the last 1.5 year, I have been working on AWS, and the services that we have usually worked on is, I would say, EMR, Glue, Athena, Lambda, and Redshift, and all those stuff. And coming to the project, mostly I have worked on streaming use cases and batch use cases as well, and somewhat little bit around data mart creation. And yeah, so.
Can you explain the business problem you are solving as part of your data pipeline and end-to-end overview, how you have running the pipeline?
Okay, so in one of the use cases, basically it was use cases basis on use case basis. So in one of the use cases, it was like let's say the customer has a credit card and he did a transaction at some merchant. So if the use case was like this, if the transaction amount is greater than some threshold value, we have to offer a card upgrade message on a real-time basis. And there are few filters like the merchant should be in this category, the transaction amount should be greater than this, the upper limit for the card should be something. So these are all the business things that we had to take care of. Now the ingestion part was data was ingested into Kafka, and we as a consumer had to write PySpark script, which will consume data from this Kafka topic and perform all the transformations. And at the same time, write to S3 after enriching the data, and after joining and performing all the transformations, we used to write it back to S3. And at the same time, write it back to relational tables as well. Now, why relational table is because, so suppose the customer did a transaction at, let's say 1 p.m. or 1 p.m. and we sent a SMS around 1-2 max, 1-2 or 1, it will be by 1-2. So it might have happened that the customer missed the SMS, right? So we write it into a relational database so that after the cooling period, after 2-3 days, we will again do a batch campaign on that and approach the customer to upgrade the card. So this was the end-to-end use case that I had worked on, one of the use cases.
So after the Kafka topic is reading, then your work is mostly consume the data.
Yes.
And just wanted to understand one thing. After the processing is happening, you are again storing the data in relational database, right? But why is a relational database? Why it's not a warehouse? You are doing? Is it a specific case why you're trying to write in conventional DB?
No, this AWS in the organization came at a very later part, and this campaign that I'm telling, the batch campaign that happens, it has been happening since long time. So it's a legacy system, and that is what is been going on. So that is, in near future they might change it, but that is what is happening. So that's why we are writing it into a relational table.
And how this notification system has been enabled?
Okay, what we do is there's this Lambda function. There's this PySpark job. What that does is it gets all the eligible customers, and we have a vendor called Gupshup. So we hit this Gupshup API with the customer details, basically the phone number and the SMS that has to be sent, and we send it to Gupshup, and the Gupshup sends the SMS. And basically we get an acknowledgement from the Gupshup whether the transaction was successful or it was a failure. Again, it's like the response that Gupshup sends, it's that it was successfully received by Gupshup. But whether the SMS was successfully sent to the customer or not, that we don't have. So it will again come at a later stage.
Okay. So in case the SMS has been sent to failure, okay, there might be some network issue or something happen. So what is there for the fault tolerance?
Okay. if for a particular batch the response from gupshup is failure, as of now we were not dealing with that, we were not handling
Mm-hmm.
that, since it was the batch use case anyway. If it has failed, it has failed, it will be taken care in the batch campaign. So but if the entire batch failed while writing to gupshup, then for that we have taken care, right? Like after sending to gupshup, we usually write it to the relational table. So if the batch campaign has failed while sending to gupshup, then what we usually do is we again check the relational table, and again since the processing has failed, so the offset would not have been committed at Kafka's end, right? So when we read the new batch again, we will get the same data. So when we get the same data, we usually do a left anti by pulling the data from relational database, and we see that okay, this data is not present in relational database. That means the data has not been, the SMS has not been sent to GupSub or to the customers. So we again resend it.
Is there any issue you have faced regarding the late arriving records in your Kafka pipeline?
Mm,
Suppose, let's say one scenario, Kafka is intends to process in real time, right? So
yes.
you're trying to process some live record, and it takes some time, maybe 2 minutes or 3 minutes. It needs to process the data, and it basically waits for that time. And at that time, some other messages are waiting in the queue,
Okay.
and some record, suppose it's coming in a delayed fashion, it's not
Okay.
coming in a particular timing. So do you know what is watermark in Spark streaming?
Sorry, I'm not aware of watermark.
Okay, okay, let's have you worked on, I mean, batch job as well, besides the streaming process?
Yeah, a few bad jobs I have worked on.
uh, just explain
Yeah,
the
sure.
use case and scenario.
Yeah. So there's this mobile banking application. So
Mm,
what happens is whenever the customer comes to the mobile banking application, sees the
mm,
offer, and drops off without giving without doing any action on that, then we consider those customers as a potential customer to send SMS, so that you can avail the offers that are available. Now in this case what happens is every 30 minutes we usually pull the data from I would say there's this again I think redshift table in which all the data is being stored. So every 30 minutes we run a job and pull these records, and we do a filtration of the customers who have dropped off without performing any action on their offers, and we again target those customers by sending SMS and notifications.
You also mentioned like you have worked on engage costing requirement gathering for pipeline automation and complex logic building of warehouse creation.
Yeah.
And so, what is that? Can you please explain those things?
So the logic building for warehouse, are you asking?
Yeah, yeah, yeah.
Yeah. So actually, one of the use cases was in which they had multiple, around 10 to 12 sources, in
Mm-hmm.
which they had address details for the customers. Now,
Mm-hmm.
it's basically for the collection team, in which if your customer defaults, then the collection team has to go to that address and do a validation, like what happened, what is the delay, and all those stuff. Now, if there's a default from the customer end, they had to check for all those 10 to 12 tables to get the exact address for that customer. Now what we did was we had to create a data mart in which we had to correlate the data or aggregate correlate the data from all these sources and create one
Mm-hmm.
specific table. And
Mm-hmm.
it was basically a SCD type 2 table in which we
Okay.
had to populate the data, and it was a single source of truth. So if we had to look for the address of a customer, we can just hit the uh, CRN number or the identification number of that customer, and we can get the latest data or latest address of the customer. So this was one of
Okay.
the use cases.
Okay. You have written that working with APIs push data on real time and developing various failover mechanisms. I guess you've already discussed that. I just wanted to know what kind of fault tolerance or failover mechanism you have implemented.
Okay, so as I mentioned, so if the batch is failing, I mentioned that we'll get the redundant data, we'll do a left entry. That was one of the case, right? The other case is, let's say we are hitting the APIs, we are sending the details, but it might happen that we have sent 5 details, and instead, after sending the 5 details, the batch got failed. So in
Mm-hmm.
this case, what will happen is, even if we get the redundant data and we send the details, so again, these 5 customers will be repeated, right? And
Okay.
to handle that case, what we did was, whenever we used to get a success response from the gupshup, uh, for the time being, I would say, for on a temporary basis, we used to store those customer numbers as a log file in S3. Now,
Mm-hmm.
whenever the data is coming, a new batch is coming, we used to read this data from S3, from the log data from the S3, and we used to check that if this data is again there, remove this data, remove the data, as well as at the same time we used to check the relational table and
Mm-hmm.
do a left anti and remove all those redundant data. So this was another failover mechanism.
What is you said left entry, right? So what is
Yeah.
left entry join and difference between left join and left entry?
Okay, so in left join, what happens? All the records which from the left side of the table. I mean, there are two tables. One table is written before the join keyword is mentioned, and one table is written after the join keyword is mentioned. So the table to the left, all the matching records as well as the records which are not matching are present in the output. That is basically the left join. So all the records from the left side of the table are present in the output. Now left anti is what? In left anti, all the records which are not present in that table will come. So let's say we have 10 records in
Okay.
left side of the table, and we have five records in the right side of the table which are present in
Mm-hmm.
left side. So when we perform a left anti, we will get
Mm-hmm.
5 records from the left side of the table which are not present in right side, basically the non-matching records.
Okay. You have dealt with Redshift in your project. Just wanted to know, do you understand the difference between sortkey and disk key?
uh, Short key and disk key, yeah, somewhat I'm aware. I mean, you can correct
Hmm.
me if I'm wrong. So
Okay.
disk key is basically the way in which the data is being distributed over the cluster. There is this round robin fashion and all those stuff, it is being there. So
Mm-hmm.
let's say, if we apply a disk key on a particular column, so
Hmm.
where the value for that particular column will be stored in the redshift, in which memory location, or we can say in which not partition, basically in which segment it will be stored, or in the way in which it will be stored, that determines the disk key. Disk key determines that. Now, after the data has been
Do
stored,
you know the types of disk key available in Redshift?
I mean, one I'm aware is round robin. Other I'm not able to recall as of now.
Okay. And what is sortkey?
Sort key. So after the data has been distributed and stored, and for a particular node, in a particular node, let's say we have 10 records. So
Mm-hmm.
how those records will be stored? I mean, if we apply a sort key on a particular column, so in that particular node, the data will be sorted based on that column. So after being stored, it will be sorted. So that it will be easier to find the record instead of scanning through the entire record, entire node.
Suppose you have to incrementally load the data in Redshift. The sources may be some on-premise transactional DB, and
Okay.
in incremental fashion, you have to load that warehouse. Okay, so
Okay.
if you want to use some AWS service to do that thing,
Okay.
which tool you will use and how?
Okay. So, though I have never done this, but I have one of the approach in my mind. So, one approach would be, I will maybe basically use a Spark job, in which what I can do is, maybe the data that is being stored in S3, I can have the maximum timestamp of the data that is being stored in S3. Now, what I will do is, this Spark job will basically query the data from the source and check like what are all the data that are greater than the timestamp that is mentioned in the Redshift. So once I get those data,
Now,
I
your
can.
source is, suppose your source is on-prem SQL Server, okay, or
Okay.
Oracle DB.
Hmm.
You have to check the incremental data based
Okay.
on timestamp, whatever you are saying,
Okay.
and then you have to load the Redshift table as well incremental.
Okay.
So that is the requirement. Okay.
Okay, so okay, so there's this service as I mentioned called DMS. So I think that can be used over here, in which DMS basically uses, I think, log-based CDC. So what this log-based CDC is, so whenever there is any update, insert, or deletion in the source side, basically there will be a log maintained in the source side itself. So instead of we performing a query on the source side, we will basically pull the details, or the DMS basically pulls the log from the source side, and it will do a automatic whatever update or delete, whatever it has to be done, it will do it in the Redshift. Now this Redshift doesn't support this merge statement, so this upsert, what we do, that it doesn't usually support. So basically if there's a insert statement, DMS can
Mhm.
usually from the log it can directly insert, but and if there is a delete, it can directly delete. But if there is a update statement, what the Redshift what the DMS can do is, it will, or what query we can write is, we can basically delete that data from the Redshift and we can do a insert on that. So this is how it can work. Basically log based CDC can be taken into consideration, and the service that we can use is DMS.
Okay. Okay, how do you implement an event-based Spark job in AWS? Suppose a scenario is whenever a file reaches on S3 location, okay, that should spin up an EMR cluster. And inside your EMR cluster, your Spark job should read an S3 file, maybe create some data frame, aggregation will happen, and it will load the data in warehouse,
Okay.
maybe in Redshift too. So how will you design this thing in
Okay.
AWS?
Okay, so whenever a data lands in S3, so the events or the things that we can trigger is maybe SQS, SNS, and event bridge. So I will take help of event bridge over here. So once the data lands into S3, the event bridge will be triggered, in which we can mention that the source will obviously be S3, the bucket name, and the target we can mention it over here as Lambda function. Now, what it will do is, once the data lands in S3, event bridge will get triggered, and the destination for event bridge will be Lambda function. And in this Lambda function, basically, we can create our EMR cluster. I mean, we can write the syntax and the all those stuff to create a EMR function, which will spin up a EMR cluster, and it will submit the Spark job. And this we can obviously keep a Spark job or a Spark script in our S3 location, and when this EMR cluster has been spun up by Lambda function, the this script which was stored in S3, we can execute this script in the EMR cluster, and after the execution of the script, we can terminate the EMR cluster as well. This we can do.
Okay. Uh, how do you? Okay, just can you explain the architecture of the EMR? What the different nodes you have in EMR?
Okay,
Do you know?
so in EMR we usually have, I think, three kinds of node: master node, core
Yes.
node, and task node.
Okay.
So a master node is basically like it oversees all the tasks and worker nodes and everything, memory allocation and all those stuff, task allocation, everything. It oversees everything. Now the main difference lies between core node and task node. So maybe I'm a bit confused between two, but yeah. So I think the task node usually uh, does all the transformation or all the jobs that has to be carried out. It is usually done in the task node. Along with that, it also has a memory of its own. So I mean, we can allocate memory for that. And in core node, what happens is, in core node only uh, there is no memory allocated to it, assigned to it, but only the job can be executed. So let's say we have assigned a EMR cluster, and in that we need compute power. So we can allocate core nodes to it, because core node will give you the I would say the compute power to perform all the job. And if we need, let's say we need to increase our compute power as well as the storage location, so in this case we can include our task node, which will, along with the compute power, it will give us the storage location as well. So basically this is the difference.
Okay. Do you understand? Do you understand what is a Glib data catalog?
Yeah, so glue data catalog basically is like a hive meta store for hive based meta store for data cataloging. Basically in Glue catalog, what happens is there are databases and tables. And let me say, like, there's this thing called Glue crawler. So whenever we have any data stored in S3, this Glue crawler will scan through the data, and it will create a metadata for that data. And this metadata will basically be stored in a table, and this table will be present inside a database. So the entire thing is called Glue catalog, which provides us with a meta store for the entire data. So this is called Glue catalog, and it can be used for querying the data and all. Instead of scanning through the source of the data, we can scan through the Glue catalog to fetch the data from source.
What do you think of how, why we can have the metadata information separate in a catalog? What kind of advantage you get if you catalog the data?
Okay, so let's say, let me tell you a scenario in which we have a use case in which the data is being read from S3, and we have created and based on that we have created a table, and that table is being used by downstream team to perform some transformation. Let's say there happened some schema evolution from the source. So we can't be always aware, or the source team will not always be aware that they have done this change, or even if they are aware, they might forget to intimate the downstream team, right? So what we can do is we can periodically run this crawler, which will always scan through this data and create a metadata table for us, in which all the columns will be there. And when the downstream team uses, so it can directly refer this metadata table, and it can know that, okay, these are the changes, this has happened, and it can directly pull the data from this table instead of going through the data. Again, if you go through the data, let's say it is stored in Parquet file or something, you can't directly see, right, what is the data type, and what are the columns, what is the size of the data, and all those stuff. So it can be directly referred from this catalog.
Okay. One of the biggest advantage of this Glue catalog that is, you can implement Redshift spectrum. Do you understand what is Redshift spectrum?
Yes.
Can you explain?
So what happens in Redshift? I would start with Redshift. So what happens with Redshift is basically we have our storage and compute cost interconnected, right? We can't segregate that. But in Redshift Spectrum, what happens is the data is stored in S3. We create an external table based on that data, and that external table will be again the external table is created. Now, when we want to perform a query, so what we can do is we can refer this Glue catalog. This Glue catalog, the crawler that created the metadata for the data that is stored in S3, we can basically query that and get the data and populate our S3. The external table that was created for Spectrum. So this is one of the most important advantage that we can get from this Glue catalog.
Do you know what is the cold start issue in Lambda?
Yeah, I'm aware of cold start issue. So basically, this Lambda is at the end a serverless architecture, right? It follows serverless architecture. So whenever we invoke this Lambda, so for whatever runtime engine we have selected, be it for Python, Rust, or Node.js, so it takes some time to initiate the instance or create the environment basically. So this time taken to initiate the environment before executing the code is called as cold start.
Suppose you are facing too much cold start in your Lambda functions, right?
Okay.
How will you mitigate? Is there any solution you can think about?
Yeah, so like if it is very time constrained thing, so what we can do, there's this thing called provision concurrency that we can use that to handle this issue. Basically, let's say for our AWS account, we can have 100 we have 1,000 concurrent instances we can run for that Lambda functions, right? Now what we can do is we can define a provision concurrency of 10 or 15. So what will happen is whenever we invoke the Lambda function, and we want invoke the Lambda function, instead of creating the so usually what happens is it creates the environment from the scratch. But now what will happen is for 15 of the instances, the environment will already be created. It's just a matter of time to execute. So it will directly execute the code. So basically the environment, all the imports and all will already be done and it will be up and running. So as soon as you invoke the function, it will start executing. So this is the thing that we can incorporate to handle the cold start issue in Lambda. So basically, yeah, it comes with additional cost as well, apart from all this thing.
Okay. Suppose you are processing a huge chunk of data, maybe 26 GB, 30 GB chunk of data. Spark, okay. So the business logic is like that you have to process the data first, then there will be some kind of data quality check. So once you process those data, there should be some kind of threshold limit for a particular column. If those things are satisfied, then only it goes to trigger another Spark job. If it is failing, then it will just filter out those records and it will dump those data in the Redshift warehouse. So basically, just wanted to know if you have this kind of complex logic, you have to trigger a series of Spark jobs in AWS. And if you want to orchestrate those things based on some logic, that if A job is success, it should trigger the B job. If B is failing, it should trigger the C. C is successful, it should put the data in Redshift. This kind of orchestration you want to implement in AWS ecosystem. How will you do that? What kind of tool you will use, and what will be your approach?
Okay, so if this is the scenario, then one use case I have done is through Glue workflow. So
Okay.
basically, in this, what we can do is, since we have, let's say, we have three glue jobs or three scripts to be executed one after another, depending on whether the previous one was successful or failure. So what we can do is we will create a initial trigger, and after that, this initial trigger will be linked to the first glue job, first Python PySpark job, and after that there will be another trigger which will basically be the condition will be all all yeah no it's all or any, but that thing will depend on whether the previous job was a success or a failure. Now if the previous job was a success, then it will trigger the second job, and if the second job was a trigger, again we will have a trigger for that, and if the second job was a success, it will trigger the third job. So this thing we can follow. Else there's another approach also I had taken. So in this, what we can do is Lambda is also very useful for triggering this PySpark jobs. We can trigger PySpark jobs in through I would say steps. In steps in EMR, we can submit the Spark jobs to Lambda, right? So that also we can do. So here, what we can do is, so this Lambda will trigger the first EMR job, and if
Okay.
this threshold that you are talking about, it meets the threshold, then it will call the same Lambda function and maybe pass a argument, let's say any argument which will tell that the first job was successful. And in this Lambda itself, we can write if else conditions to check what was the value passed from this glue job, and if it satisfies, call the second job, or else call the third job, or do whatever you want. So this is a very, I mean, I feel that this approach is very good because, I mean, we'll have a programmatic control over that. So this is one of the approach also that I had followed.
Tell me one thing. Okay, so Glue workflow is fine. You
Okay.
can orchestrate
Yeah.
whatever the Spark jobs you want. You can do that. But Glue, whatever the problem is, that Glue is tightly coupled with the AWS ecosystem only.
Okay.
If your client wants to have your data stored in Snowflake, so Snowflake is a third-party warehouse.
Okay.
I guess Glue workflow can't integrate with Snowflake. So
Okay.
in that scenario, what kind of orchestration tool you will use?
I mean,
Any idea on that?
yeah, if you're looking for a orchestration tool, so I will obviously go with Airflow, which I have not worked with, but yeah,
Okay.
Airflow would be the thing, the tool to go for.
Got it. What kind of orchestration tools is there in your project?
To be frank, I mean, we use only this glue is there, glue workflow, and we get the logs through CloudWatch, and we have shell
Mm-hmm.
script in which we write all the logs. So these are the ways in which we check the jobs. There's basically we don't use any specific tool for that.
Got it.
I mean, we had explored Airflow, but Airflow did not fit into our project. I mean, the cost of Airflow itself was greater than the use case itself, so we did not go for
Um, got it. Uh, do you have understanding on Lakehouse architecture?
a lake house. It basically, I mean, yeah, it's a combination of data warehouse and data lake. Though I have not
Mm-hmm.
worked on, but yeah, somewhat I know. I mean, it's a combination best of both. Data lake, which stored all kind of data, structured, unstructured, and semi-structured data, and data
Mm-hmm.
warehouse, which is known for its ACID compliance and all those stuff, and relational tables and all. So it combines both of this. So basically, we can have structured, semi-structured data along with ACID compliance.
Okay, got it. So the thing is like in previously in Hive, we didn't have that kind of capability for ACID
Okay.
transaction, right? So if your client requires some Hive migration kind of script, which should update the column name or rename some kind of table, normal in Hive it is not that much feasible to do that.
Okay.
So how you can implement Lakehouse architecture in your AWS ecosystem? Maybe you have Hive tables and the underlines are the Parquet files, but now you want ACID capability on top of that, right? Any idea how you can do that? Those things.
Okay, so I mean, it's quite tricky, and I mean, uh, it's a difficult scenario for me to think on. But yeah, I can give it a try.
Mm-hmm.
Maybe first approach that will come to my mind is obviously to see. Let's say we have, I mean, the scenario that you mentioned, underlying
Mm-hmm.
files will be Parquet here, right? So it's
Yes.
basically this Athena table. Let's say Athena table is there, which has external tables and underlying files are Parquet files. Let's
Mm-hmm.
see that. So here also it is not ACID compliant, right? So whenever we have to change any column name, so
Mm-hmm.
what I can do is maybe either do a alter table, which
Mm-hmm.
usually results in error. I mean, for my case, it usually, and we have to debug it what happened. But what I would do is easily create another table. Just I have to copy the create statement, create table statement, and modify the column name. At the same time, I can do a select. I mean, create table with that schema and do a select statement from the previous table. So this create external table as select star from this previous table that I can do and map the column. So this is one thing that I can do. And other thing is if we consider or create our architecture with this mindset that yeah, this might happen, then what we can do is basically there's this thing called whenever we create just give me a second. Yeah, so yeah, whenever we create our Athena table, right? Yeah, correct. Whenever we create our Athena table, what happens is there's this either we use Parquet file or some file. So there's this property called, I think, Surday properties. So for that, if it is a Parquet file, by default, what it does is it maps the column names for Parquet file. So column name of Athena table should be mapped with the column name in the Parquet file, right? By default, it is that. But if we enable this property, this Surday properties, so what it will do is it will not go for the column name, rather it will go for the column index. So if we have enabled this property, then if we directly alter the column name in Athena table, so anyway the index of the column is not changing, right? Only the column name is changing. So we can directly alter table with alter table and replace column we can do in Athena, and it will work as good as previously it was working.
Okay. Okay, fine. Let me give you an SQL problem. Maybe you can share your screen. Let me Let me send it through your chat first.
Okay.
Then just give me a moment. Send this. Okay. You just copy paste the
Okay.
actual
Yeah.
input and output in your notebook.
Yeah. Is my
Okay.
screen visible?
Yes. Yes.
Yeah.
So basically,
Hmm.
the first, whatever the input table you have, right?
Yeah.
Uh, you can think it like a tracker table, which basically tracks down whatever the services are running on in your cluster. Maybe some HDFS daemon is running on, maybe some other Hive process is going on. So it will basically check which process is running for what time. So
Okay.
there will be an updated time and the status for that. So you have to understand that which services is down for more than 3 minutes. So if you see for a particular instance, HDFS was down. First, it triggered down as 10:2 and it was down till 10:6. So it's more than 3 minutes, right?
Okay.
So if it is more than 3 minutes, then if you have to create the output where there will be service name, so start updated time, end updated time, and the status is meaning the for which bandwidth, for which time zone it was down.
Okay.
And you have to create the output only if the start updated time and end updated time is more than 3 minutes. So here it is from 10 to 10 to 6, so it's around 4 minutes.
Okay.
Think the problem first. You can discuss what kind of approach do we follow.
Okay.
Then you can start writing them.
Yeah. I mean, so if it is down for more than 3 minutes, so basically we have to maybe keep track of uh, when was the first time it got down, and and uh, and after the first down, when was the first time it was up? Let's say for line number 8, it got down for the first time, and after being down it was up for the first time at line number 13.
Correct.
So maybe what we can do is just the we can get the lag of line number 13, the previous value, that will be again a down, right?
Mhm.
So we have line number 8 and line number 12 in memory. I mean, we have a cursor on that, and we will do a difference maybe. I mean, I'm just thinking like if we do a difference and check that, okay, if the time is greater than 3 minutes, then these two rows, line number 8 and 12, can be considered as the output, and in which we will consider the updated time for line number 8 as the start time, and updated time for the line number 12 as the end time.
Okay, so you can start writing whatever you're thinking of. I just want to add one thing. In
Yeah.
service name, in the data set, it's only HDFS.
Yeah.
But what I'm trying to convey, there might be some other services as well. Hive, some DynamoDB, some other services as well. Okay.
Okay.
So maybe some other services is also getting down from more than 3 minutes. So you have to take down all the services. So that is whatever you have to consider that thing as well.
I got it. I mean, yeah, the logic that I said was like it's easier said than done. So, I mean, I'm still trying.
If we'll do a lead and lag, what will happen? It will try to calculate lead and lag record for every row, right?
Yes.
So even suppose the first row is HDF, and the second row is Hive, you
Okay.
don't able to understand.
Correct.
But that lead lag shouldn't be calculated because in that scenario, these two are different services. Lead lag should be calculated if it is only the same service.
Got
So
it.
that thing you have to also consider when writing the.
Okay. So, uh, for that, I mean,
You can start writing the code. I guess if you start
no.
writing the code, then
Yeah.
you'll
I
find
mean,
the nuisance.
yeah. I mean, as I said, it's very easy to say. I mean, the logic from my end, I said it, but I mean, I'm just
The
trying.
logic is correct actually. Whatever you are trying to say, that logic is the logic will work, but you have to write it down.
Okay. Uh,
Take your time and just try
yeah.
to write it down.
Uh, if I get the first down, so when was it down for the first time?
Try to think to implement some other window function as well beside lead and lag if it
Yeah.
helps.
If I apply a window function uh, on part, and if I partition it by status, so I'm just thinking, will it work? Because if I partition it by status, then I don't think it will work over here because
Look, if you partition it by status, then what will happen? All the services
yes,
which is under down or up, it will come to a particular place. But we don't
correct.
want that. We want to compare if the same services is down for a particular time. So that won't work, I guess.
Yeah. Mm, I think like as of now, I'm getting a little bit frozen out.
Okay, okay. Okay.
So
Not an issue. You can think this problem later.
yeah, yeah, sure, sure.
It's a nice problem, and you can think it.
Definitely, I will look into it.
You can stop sharing it. Uh, Fine, Abhishek. So that's all from my end. I'll just little bit wanted to discuss feedback and
Yeah,
whatever I felt about this session. Maybe.
yeah,
So the first thing is two things. Okay, so you have to know the project end-to-end project idea, even if for a particular part you are not working, right? But in interview when we'll be explaining your project architecture, so
okay,
you have to be well aware about the ingestion, how ingestion is happening, and ultimately how the data flows into your custom. Everything you have to do in very
okay,
detail because interviewers are they often tend to ask you questions around your project, and you can impress your interviewer that you know your project very well enough, then it will be easier for you to crack those interviews. So this
okay,
is the first point. The second thing is whatever you are mentioning in your resume, right? Whatever AWS services you are
mm,
mentioning, uh, so you have to be at least know the basic terminologies and the definitions. Maybe if you are not working, maybe you are not creating any list or sort in Redshift, but
Okay.
these are the very basic feature. Uh, and always just try to have a overall architecture sense. Right? What is the basic Redshift architecture? What
Got it.
is compute node? What is dense node? So this kind of little bit, because you have mentioned
Yes.
Redshift, right? And there are different type of sort keys and list key. There are interleaved sort key,
Okay.
intercompound sort key. Those things are there. Just little bit study about those things, because
Yes. Sure.
interviewer might expect you to answer those things as you have mentioned in the issue. Right?
Yeah.
Also, in you have also worked on streaming scenario, right? So there is a common phenomena which is called late arrival record. There are, I was talking about the
Yes.
watermark policy. So these are the basic, very common use cases where your pipeline record in real time, you're getting a delayed record. How will you handle those kind of scenarios?
Okay.
A little bit about those will help you.
Sure.
And then incremental load, right? So I was asking you if you want to use some kind of AWS service, which is basically help to load the data incrementally from an on-premise DB and load it to a
Okay.
Redshift cluster maybe. So you said about DMS, but I believe DMS is data migration service, and
Yes. Yes.
it is mostly a lift and shift kind of service. So it's a migration tool. It's not basically used for incremental work.
Okay.
You could talk about there is a feature called bookmarking job in Glue. So
Okay.
what happens with bookmarks, and it checks from the last point the data has been read, and it will basically do not reprocess the data from beginning. It will bookmark that particular key. You can also define for which key you want to bookmark your job. So Glue is basically a central component of AWS data engineering. There are a lot of features around Glue. Okay, so study well about Glue. There are
Okay. Sure.
these things. There is also some data quality check you can do
Okay.
around Glue. Interviewer might expect you know how data quality check has been done through Glue. There is and many more stuff is there. So study about these tools very well. Lambda, Glue, Redshift, EMR, S3. So whatever the S3 services, AWS services you have written, study these things, and later on, if you are getting some time, I'll suggest you to do for the certifications as well. There is
Okay.
a recent certification AWS, which AWS has released. It's called AWS Data Engineering Certification. So
Yeah.
basically in that certifications, all the AWS data engineering related tools they have incorporated. So if you
Yes.
go through the curriculum, you will be well versed about each and every tools and what are their capability. Because if you are trying to create your career in a particular cloud domain, maybe after 5 to 6 years, your responsibility will be architect on that particular cloud platform, right?
Correct.
So if you have a good knowledge in the tools, it will basically help you.
Got it.
So this is one thing. Another things like data orchestration, whatever you have told with the Glue workflow, that is the correct answer. Glue catalog you have explained well. Advantage of data catalog, EMR architecture, these things you have explained well. EMR autoscaling you have fumbled a little bit. You can study those things as well. Lakehouse architecture you also explained well. Implementation of Lakehouse architecture in AWS, like delta tables are there in Azure, right? In AWS,
Yes.
you can implement something called iceberg or hoodie tables. So
Okay.
these are basically transactional data lake on top of Parquet file, similar to the delta tables. So maybe just little bit, whatever
Hmm.
you have, around 2.5 or 4 years of experience, right?
Yeah.
Yeah, maybe a little bit study about those things uh, can make you fit enough to like the interview seconds. But
Sure.
overall, it's a good sessions, and also, yeah, very crucial thing. Uh, you should be very much well versed about easy to complex level of SQL problem. Any kind of SQL problem they can give you in the
Yeah.
interview. Okay. If it is a Python DSA round, least three, this kind of thing they can ask you, but that is easy to medium level, I believe. But
Okay.
for SQL question, they can ask you in any extent of.
Okay.
So that is my feedback. In case it will help you. And
Definitely.
anything from your end?
Yeah, I mean, I would say it was a great learning experience for me. Like, uh, I was not expecting that we can go to this depth for data engineering for these
Hmm.
services, and I was even not aware of this bookmarking thing in Blue, and it was a great learning experience. I mean, it opened what I would say plethora of pathways for me to explore,
Hmm.
and I will
Okay.
definitely do that.
Okay.
And coming to SQL, yeah, SQL, I would say I'm good with SQL, but that I understood that again, being good is not enough. You have to
Hmm.
be the best. That is what I feel.
Now you have to practice well enough so that in
Yeah,
interview room you'll get very less time, and you have to come
correct,
up with a basic solution at least. Maybe on top of that solution you can work, you can discuss
correct.
with your interviewer, but you have to
Okay.
come up with a basic template.
Yes.
That thing is expected.
Yeah.
Okay, fine. We'll meet again sometime soon.
Yeah. Sure. Sure. Sure.
Thanks. Thanks for this.
Thanks. Thanks.